Okay, welcome back. We're in section 7.2, which is actually part 2 of inverse trig functions. Now, if you notice the problem I have on the board, I am taking the tangent of cosine inverse of a half. Here's the deal. Tangent and cosine inverse clearly are not inverses of each other. They are not going to cancel each other out, correct? So, something that we need to look at is inside the parentheses, or brackets in this case, because according to the order of operations, that's what comes first. So the first thing we're going to look at is the cosine inverse of a half. We need to figure this out. When we figure this out, we can then figure out the tangent. So now, we need to ask ourselves, is 1/2 the angle or the answer? Give you 1 second to think about it. Time's up. Okay, so I'm hoping you said it was the answer because the first thing you're doing is taking the cosine inverse of it, which means this is the answer, which means you're looking for theta. Agreed? Now, I like to deal with just the cosine function, not necessarily the cosine inverse. So I'm going to take the cosine of both sides, and when I do, I end up with the cosine of theta equaling 1/2. Are you with me? All right, so back to the original problem. Since cosine inverse of 1/2 is equal to theta, that means you're actually trying to find the tangent of theta. Answer me this. Do I really care what theta is, or do I really care what the tangent of it is? I really care what the tangent of it is. I don't really care about theta itself. So, check this out. Cosine of theta equals 1/2. Agreed? I can draw a triangle . And it needs to be a right triangle because cosine only works on a right triangle. I can put theta anywhere I want on this triangle. It doesn't really matter. Me personally, I always stick theta down here. Doesn't matter. But what I do know is that the cosine of theta equals 1/2. And when I'm on a triangle, cosine is the adjacent side over the hypotenuse, which means the side adjacent to theta is going to be 1. The hypotenuse is going to be 2. Now, some of you are like, wait, I know this triangle. And that's cool if you know this triangle. But even if you don't know this triangle, because some of the problems they give us, we're not going to know the triangle, then this is helping you figure it out and set it up. The one missing side is this one. So in order to find the side, I need to use Pythagorean Theorem. A squared plus b squared equals c squared. And when I use Pythagorean Theorem, excuse me, I end up with this side being the square root of 3. Y'all with me? Okay. Now, you may know what theta is. You may not know what theta is. Let's just pretend we really don't know what it is. The problem asks me to find the tangent of it. Here's theta. Tangent is the opposite side over the adjacent side, which means in this case, I am going to take the square root of 3/1, which is just going to equal the square root of 3, which means the tangent of the cosine inverse of 1/2 is simply equal to the square root of 3. Cool? All right, then let's try another one. Okay, so here's problem 2. They're asking us to find the secant of sine inverse of 2 square root of 10/7. So clearly, secant and sine inverse are not going to cancel each other out. They're not inverses of each other. which means we need to work according to the order of operations. And the order of operations says do what's inside your parentheses first, or in this case, our brackets, which means the first thing that we need to look at is the sine inverse of 2 square root of 10 over 7. Now, we need to figure out, is 2 square root 10 over 7 the angle or the answer? Give you 1 second. Correct. This is the answer, which means we're trying to find theta. We're trying to find the angle, which means the original problem, what we're really trying to do in the original problem is find the secant of theta. Now, some of you are okay with working with it this way. Some of you are not. So for those of you who are not, remember, take the sine of both sides. And when you take the sine of both sides, you will end up with 2 square root of 10 over 7 equaling the sine of theta. Now, I clearly do not know what angle that when I take the sine of it's going to give me this wonderful little answer. So I'm going to draw a triangle. Because here's the thing, I really don't care what theta is. What I really care about finding is the secant of that angle. That's all I really care about finding. So, draw my triangle. I'm going to put theta here. What I know about sine, it is the opposite side over the hypotenuse. So my opposite to theta is 2 square root of 10. My hypotenuse is 7. I'm missing this side down here. You need to use Pythagorean Theorem. So I'll work this one out for you because some of you may not be too happy with finding this side using that as your A. So I'll call that B. So to find B, use Pythagorean Theorem. Here's your A squared, or your A being squared, plus B squared equals your hypotenuse squared. Well, clearly that's 49. Remember, since this is multiplication, this is 2 squared times the square root of 10 squared. That's going to be basically 4 times 10. And 4 times 10 is, that's right, 40. So 40 plus b squared equals 49. And if I look at it over here, b squared is going to be equal to 9. B is either equal to a positive 3 or b is equal to a negative 3. So which one is it going to be, a positive 3 or a negative 3? I hope you said a positive 3. For one thing, it didn't tell me anything about a quadrant. And if it didn't tell me anything about a quadrant, then I'm going to assume we're in quadrant 1, which means in this case, b is going to be equal to 3. Now, to find the secant of theta, you got to remember, secant is the reciprocal of cosine, correct? Cosine is your adjacent over your hypotenuse, which means secant is going to be the hypotenuse over the adjacent, which means in this case, your answer is going to be 7/3. How are we doing? Y'all with me? Does that make sense? Good. And so that'll wrap up section 7.2, which is part 2, the inverse trig functions. See you later.